Presenting.
Okay, is it audible? ఓకే, వాయిస్ క్లారిటీగా ఉందా లేదా ఒకసారి చెప్పండి నాకు. ఐ యువర్ స్క్రీన్ ఈజ్ బ్లర్. ఓకే, మీరు రిజల్యూషన్ చేంజ్ చేసుకున్నా అన్న. ఓకే, ఐ థింక్ 480 అదర్వైజ్ 720 పిక్సెల్లో పెట్టేసుకోండి బెటర్. ఓకే, రైట్. కెన్ ఐ స్టార్ట్? ప్రజెంట్ 40 మెంబర్స్ లైవ్లో ఉన్నారు. ఓకే, రైట్. సో ఐ విల్ స్టార్ట్. ఓకే, ఓకే, లాస్ట్ క్లాస్లో 2 క్వశ్చన్స్ ప్రొవైడ్ చేశాను మీకు. వాట్ హ్యాపెన్స్ టు ద కండక్టివిటీ సిగ్మా ఆఫ్ all the conductors when the temperature increases from room temperature? సో ట్రై చేశారా మీరు ఎవరైనా? ఓకే, రైట్. సో ఫర్ ఫస్ట్ క్వశ్చన్, when the temperature increases, when the temperature increases from room temperature, room temperature is nothing but 27 degrees centigrade, right? 27 degrees centigrade, otherwise 300 kelvins. Okay, so now, so our question is what happens to the conductivity sigma of all the conductors when the temperature increases from room temperature, right? So here, so our normal temperature is what? 27 degrees centigrade. Okay, otherwise 300 kelvins. Okay, from this temperature I am increasing, right? So from this room temperature I can increase the temperature. Now what is the conductivity of conductors? Okay, how the conductivity will be changes? So that is the question, right? So here this is our conductor. Here I am taking positive ions and free electrons. Okay, so now I am increasing the temperature, right? I am increasing the temperature for this particular conductor. Okay, so now when we are increasing the temperature, so the free electrons movement also increases, right? When we are increasing the temperature, the free electron movement also increases. Okay, సో అంటే మీరు ప్రీవియస్లీ టెంపరేచర్ అప్లై చేయడానికంటే ముందు ఏ స్పీడ్తో అయితే ఇవి మూవ్ అవుతున్నాయో మీరు టెంపరేచర్ ఇంక్రీజ్ చేశాక అప్పుడు వాటి స్పీడ్ వచ్చేసి ఇంక్రీజ్ అవుతుంది. స్పీడ్ని మనం ఇక్కడ టెక్నికల్గా కైనెటిక్ ఎనర్జీ అనుకుంటే బెటర్, రైట్? కైనెటిక్ ఎనర్జీ ఆఫ్ దట్ పర్టికులర్ ఎలక్ట్రాన్. In general, we can call it as speed, but when comes to technical terminology, which is called as kinetic energy of that free electron. Okay. Now that means if you increase the temperature, kinetic energy of electron also increases. Kinetic energy in the sense that the speed of that particular electron also increases. Okay, so when the speed of free electron increases, okay, so what we expect in this conductor, so these electrons are moving with higher speed. In that situation, what we expect in this particular conductor, definitely there should be collisions, right? That means electron to electron collision, electron to ion collision. So that why? Because these ions are immobile, but which are oscillate in its position, right? So which are oscillate in its position. Okay, and these ions are oscillating and the free electrons are moving in a speed manner, right? So in that situation, so we are expecting collisions between electrons to electron and electrons to ions also. Okay, so due to this increasing of kinetic energy, collisions also increases. Okay, collisions also increases, right? So because of the, for example here we can take one free electron which is moving higher speed, that means higher kinetic energy. So because of that speed which is collide with this particular electron, otherwise this particular ion, so in that situation what happened, the entire velocity of that particular free electron is decreases or not. If you are moving certain, if you are moving with certain speed, okay, so in between you can get one barrier. Okay, now you can collide with that barrier, so obviously your speed decreases or not. Okay, because of that decrement of speed, okay, that means the speed of otherwise velocity of electron falls. Okay, so because of this decrement of speed, otherwise decrement of velocity of that particular free electron, okay, will affects the mobility of free electron. That means mobility also decreases. Okay, mobility also decreases. How the mobility decreases means, that means mobility means what? Movement, right? So one place to another place movement. Because of decrement of this velocity, obviously mobility also decreases. Otherwise you can take in this way also. So velocity is nothing but what? This velocity directly proportional to electric field. In general, these electrons is in static mode, right? Without any electric field, without any supply. So these conductor having static electrons, right? Static electrons in the sense electrons are in rest, right? Electrons are in rest mode. Okay, that means before applying electric field, these electrons all are in rest mode, that means static mode. Okay, so that means there is no movement at all. Okay, without electric field there is no movement of free electrons, right? So if we want to produce the movement of electrons, so we need to supply certain amount of electric field here. Okay, so electric field in the sense what? Electric field equals to voltage per length. That means if you apply one battery for this conductor, okay, plus minus voltage. This voltage per length will equals to electric field. If you are applying certain amount of electric field for this conductor, there should be a movement of free electrons, right? So that means what? Vd directly, movement in the sense what? Which are moving with certain kinetic energy. Kinetic energy is nothing but what? Ke equals to half into mv square. M is mass of electron, v is nothing but velocity of that particular free electron, right? So this velocity of that particular electron directly proportional to applied electric field or not. So now if you remove this proportionality constant, so that Vd equals to mu into E. So here mu is our proportionality constant, okay, which is also called as mobility of that particular electron, okay, that means which represents movement of that particular electron, okay. So because of collision, if you increase the temperature, kinetic energy increases, kinetic energy of that free electron increases, then collisions increases due to that higher kinetic energy, then obviously velocity of electron decreases. So if velocity decreases, mobility falls, okay. If mobility decreases, then what happens? Conductivity of conductor mainly function of mobility of free electron. I already stated in the beginning class, right? So the conductivity of the material depends on two things. One is number of free electrons, and the second one is mobility of the free electrons, right? So here when you increase the temperature, so ultimate outcome is what? Mobility decreases. If mobility decreases, what about conductivity? Sigma also decreases, right? So what is our question? What happens to the conductivity sigma of all the conductors when the temperature increases from room temperature? Okay, so conductivity decreases, right? When temperature increases, kinetic energy increases, kinetic energy of electron, right? So due to that, what happened? Collisions increases. Due to that collisions, velocity of electron decreases. Not only one electron, so group of electrons velocity decreases. So that will leads to decrease of mobility of free electrons. So which tends to decrement of conductivity, right? So this is your answer, okay. Now the second question is what? Why voltage drop in any practical conductor whenever it carries electrical energy? Okay, if some conductor carrying electrical energy, energy is nothing but current, right? For example, this is one conductor, okay. Here we are connecting one supply voltage battery, that is V, okay. So if you are connecting this battery, after certain time interval, this entire conductor heated up, right? If you continue that voltage still, so then this temperature increases continuously, ఓకే. అంటే మీ ఈ వోల్టేజ్ సోర్స్ని అలాగే కంటిన్యూగా ఆన్ చేసి ఉంచారు అంటే ఈ కండక్టర్ ఒక టెంపరేచర్ ఏమవుతుంది, కంటిన్యూస్గా ఇంక్రీజ్ అవుతుంది, ర్యాపిడ్గా గ్రో అవుతుంది. ఇంకా ఇన్ జనరల్గా చెప్పాలంటే మీరు యూస్ చేసే మొబైల్ కంటిన్యూస్గా యూస్ చేస్తున్నారు అనుకోండి, అప్పుడు ఏమవుతుంది, కంటిన్యూస్గా డివైస్ హీట్ అనేది కంటిన్యూస్గా ఇంక్రీజ్ అవుతూ ఉంటుంది, రైట్? సో ఇక్కడ కూడా అంతే. సో కంటిన్యూస్గా సప్లై అనేది ప్రొవైడ్ చేసేసి ఒక డివైస్ని ఆపరేట్ చేస్తున్నాను అంటే, సో ఆబ్వియస్గా టెంపరేచర్ అనేది ఇంక్రీజ్ అవుతుంది, ఓకే. ఆ టెంపరేచర్ ఇంక్రిమెంటే మనం ఇక్కడ వోల్టేజ్ డ్రాప్లా కన్సిడర్ చేస్తున్నాం. ఆ వోల్టేజ్ డ్రాప్ అనేది ఎందుకు ఎగ్జిస్ట్ అవుతుంది అని చెప్పేసి ఇక్కడ క్వశ్చన్ అడుగుతున్నాను, ఓకే. సో నౌ హియర్ okay, as E increases, there exists an increase in collisions, between the free electrons and immobile positive ions. positive ions, which are larger in size. Okay, which results fall in the drift velocity. Here drift velocity equals to what? Vd equals to mu into E, where mu equals to mobility of electrons and E is applied electric field, right? Okay, otherwise okay, drift velocity, and hence loss in kinetic energy, that is Ke equals to half into mvd square, which are measured in joules. This loss in energy will be dissipated in the form of heat energy, which results in voltage drop across the conductor. Okay, so now here Vd equals to drift velocity equals to mu into E, so where mu equals to mobility of free electrons, so and units are meter square per volt second. Okay, and when comes to E, electric field, that is applied electric field, so units are voltage per length. Okay, and Vd equals to what? Drift velocity, that is volts per meter. Sorry, meter per second. Okay, okay, now and here kinetic energy Ke equals to half into m into Vd square. So here Vd is nothing but drift velocity, already we know, which is measured in terms of meter per second, where m equals to mass of electron. Okay, where m equals to mass of electron, that equals to 9.11 into 10 power minus 31 kgs. Okay, okay, so as E increases, that means electric field increases, there exists an increase in collisions between free electrons and immobile ions, which results fall in the drift velocity, and hence loss in kinetic energy. This loss in energy will be dissipated in the form of heat energy. Okay, which results in the voltage drop across the conductor. Okay, for example, so here you can observe in the previous case. So in the previous case, here we are increasing temperature. Okay, if you increase the temperature, the free electrons movement increases. Not only temperature, if you increase electric field also. Okay, if you increase electric field also, this movement of free electrons increases, right? Temperature is one reason, and electric field another reason to increase the free electron movement. Okay, don't depend only one factor. Temperature also affected, that means which affects the electron speed, and electric field also affects the speed of electron, right? So in the previous case temperature increases, right? So but in this question we are increasing electric field. If we increase the electric field, the free electron movement increases. The free electron movement increases, right? The free electron movement increases. Movement means the speed of the electron increases. The speed in the sense what? Kinetic energy of that particular electron. Kinetic energy in the sense what? Ke equals to half into mvd square. Here vd is nothing but what? Speed of, that means the velocity of that particular electron. Velocity or drift velocity, not at all problem. Okay, that means which are moving from one place to another place, so that's why we are calling drift velocity, right? So the drift velocity of the electron increases while increasing the electric field. Okay, because of this kinetic energy, because of this higher kinetic energy, the collisions of electrons, okay, the collisions of electrons, otherwise collisions between electrons and immobile positive ions increases, right? Because of that collisions, the kinetic energy will be decreases. Because of that collisions, kinetic energy decreases. Okay, so whenever collisions will be taking place, each and every collision causes certain amount of temperature, right? If for example this is your free electron, okay, and which is collide with this positive ion, right? So this is higher in size, okay, 1837 times higher when compared to this electron, right? So now this electron is collide with this positive ion. Definitely there should be a temperature, that means there should be a cause of temperature, right? Because of this collision, like that. So number of free electrons collide with the number of positive ions. In that case temperature increases. Okay, the temperature here we are considering one energy, right? So and hence loss in kinetic energy, this loss in energy will be dissipated in the form of heat energy. That heat is nothing but what? Temperature. Because of these collisions we can get temperature. The temperature is produced throughout this conductor while connecting this voltage source, otherwise electric field, right? So the temperature is nothing but voltage drop. Okay, while carrying current through this particular conductor, there should be a heat. That heat is nothing but voltage drop across that particular conductor. Okay, so now క్లియర్ కదా ఇది మీకు? ఇక్కడ ఏంటంటే ఈ ఎలక్ట్రాన్స్ ఇందులో క్యారీ అవుతున్నప్పుడు మనకి ఇక్కడ వోల్టేజ్ ఇంక్రీజ్ చేస్తే మూమెంట్ అనేది ఇంక్రీజ్ అవుతుంది. మూమెంట్ ఇంక్రీజ్ అవుతే కొలిషన్స్ ఇంక్రీజ్ అవుతాయి. కొలిషన్స్ బిట్వీన్ ఎలక్ట్రాన్స్ యాజ్ వెల్ యాజ్ పాజిటివ్ అయాన్స్. సో ఈచ్ అండ్ ఎవ్రీ కొలిషన్ కాజెస్ సర్టెన్ అమౌంట్ ఆఫ్ టెంపరేచర్. ఓకే, ఆ టెంపరేచరే మనకి హీట్లా ప్రొడ్యూస్ అవుతుంది. ఓకే, ఆ టెంపరేచరే మనకి ఇక్కడ హీట్లా ప్రొడ్యూస్ అవుతుంది. ఆ హీట్ ఎనర్జీనే మనం ఇక్కడ వోల్టేజ్ డ్రాప్లా కన్సిడర్ చేస్తున్నాం, రైట్? హీట్ ఎనర్జీని మనం వోల్టేజ్ డ్రాప్లా కన్సిడర్ చేస్తున్నాం. ఓకే, నా ఈవెన్ మీరు మొబైల్ యూజ్ చేస్తున్నప్పుడు హీట్ అవుతుంది కదా, మీరు సప్లై నుంచి వెళ్ళి, అంటే బ్యాటరీ సప్లై నుంచి వెళ్ళి మీరు బ్యాటరీని ఛార్జ్ చేస్తారు. ఓకే, బ్యాటరీని ఛార్జ్ చేసిన తర్వాత దాన్ని యూజ్ చేస్తున్నారు. ఓకే, యూజ్ చేస్తున్నప్పుడు ఏమవుతుంది, మీకు ఆ హీట్ ఎనర్జీలో, హీట్ ఫామ్లో ఎనర్జీ వచ్చేసి కంప్లీట్గా డిసిపేట్ అవుతుంది త్రూ దట్ పర్టికులర్ డివైస్. అంటే బ్యాటరీ ఏమవుతుంది, అక్కడ డ్రైన్ అవుతుంది అన్నట్టే కదా. సో అంటే ఆ ఎనర్జీ అనేది లాస్ అవుతున్నాం. బ్యాటరీలో ఏదైతే ఎనర్జీని స్టోర్ చేసామో అదే ఎనర్జీని హీట్ ఫామ్లో మనం డిసిపేట్ చేసేస్తున్నాం. అంటే బ్యాటరీలో ఉన్న ఎనర్జీ హీట్ ఫామ్లో డిసిపేట్ అవుతుంది. ఓకే, సో సేమ్ ఇక్కడ కూడా అంతే. ఏ కండక్టర్ అయినా తీసేసుకోండి, ఏ పాసివ్ ఎలిమెంట్స్ అయినా తీసేసుకోండి, త్రూ దట్ సర్టన్ అమౌంట్ ఆఫ్ ఎలక్ట్రికల్ ఎనర్జీ క్యారీ అవుతుంది అని అంటే డెఫినెట్గా కొల్యూషన్స్ అనేది జనరేట్ అవుతాయి. డ్యూ టు దట్ కొల్యూషన్స్ హీట్ అనేది ప్రొడ్యూస్ అవుతుంది. హీట్ ఫామ్లో ఎనర్జీ లాస్ అవుతుంది అని అంటే వోల్టేజ్ డ్రాప్ అనేది జనరేట్ అవుతుందని దాని మీనింగ్. వోల్టేజ్ డ్రాప్ ఇన్ ద సెన్స్ వాట్? Heat energy, simply says. Okay, now next page. Okay, right? So the amount of power dissipated within conductor the amount of power dissipated within the conductor, that is P equals to the dissipated power. Okay, this one is a dissipated power, which is equals to J into E. Okay, so here J is nothing but current density, E is nothing but electric field, right? So what are the units of current density? Ampere per meter square. And what are the units of electric field? Voltage per meter. So if you combine these two, ampere voltage per meter cube. Ampere voltage is nothing but what? Power. So that here we can take, that means watts, right? So watts per meter cube. Okay, power dissipated power in terms of watts per meter cube, right? Now P equals to, but what is the value, what is the expression of J relationship? J equals to what? Sigma E, right? Where sigma equals to conductivity, otherwise proportionality constant. Same thing you can substitute here, right? So what you will get? Sigma E into E. So P is equal to, sorry, P is equal to sigma E square. So this is your dissipated power expression. So which is in watts per meter cube. The dissipated power measured in terms of watts per meter cube, right? So here power density, that means power dissipated, per unit volume, otherwise unit cube, okay, within the conductor. Due to resistance, resistance effect of the conductor. Okay, now due to this effect, the conductors get heated up. Okay, so here what is the observation? As E equals to 0, for example, if I am taking electric field equals 0, that means applied electric field equals 0, then applied electric field is equals 0 is nothing but kinetic energy of electron equals to what? 0. Kinetic energy of electron 0 means what? Drift velocity of electron 0. Drift velocity of electron 0 is nothing but what? Mobility also 0. Mobility of electron also 0. So that means kinetic energy of that particular electron 0. So drift velocity of that particular electron equals 0 and mobility of that particular electron also 0. In that case, what happened? So mobility 0 means what? All the electrons are in static mode, otherwise rest mode. Static mode or rest mode. Okay. Now if you are taking power dissipation, that equals to what? J into E, right? But here, so if E is equal 0, electric field equals 0, okay, so then if electric field equals 0, so power equals to what? 0. That means dissipated power through the conductor, equals to 0, only when only when no electric field, only when no electric field, otherwise electric field equals to 0. Okay, that means what? When no energy, when no energy flow through the conductor, then no voltage drop, no voltage drop across the conductor. So we can expect voltage drop only when electrical energy carrying through that particular conductor. If there is no electrical energy flowing through conductor, then we cannot expect any voltage drop across that particular conductor. Okay, this is the final conclusion. Not only conductor, if you take any element, okay, if you take any passive element also, if current is carrying through that particular element, there should be a voltage drop. Okay, for example, if I am taking three passive elements, right, we have three passive elements. Three passive elements, those are resistance. Okay, this is resistive element, and next inductor. Okay, this is for inductor, and next capacitor. This is our capacitor, right? So here current is carrying in this particular direction. So current is carrying in this direction. Here current is nothing but what? Electrical energy. So current in the sense what? Electric current, otherwise electric energy. Okay, electric energy. So this electric energy carrying through this particular element, right? So this is R and this is L and this is. So when current carrying from this direction, so this terminal can be indicated with the plus and this terminal can be indicated with minus. This is plus and this is minus and this is plus, this is minus. When current carrying through this particular element, so we can expect voltage drop across this particular element. So that is called VR. Here VR is nothing but what? Voltage drop across the resistor. Okay, voltage drop across this particular element. Here the element equals what? Resistor R. Okay, and in the same way, if current carrying through this particular inductor, so we should expect voltage drop across this particular element, that is VL. So here VL, voltage drop across the inductor. Across the inductor L. So in the same way, here we can expect VC, that VC is nothing but voltage drop across the capacitor C. Okay, so from these three elements in general, so we can conclude that conclusion from above three statements, we can conclude whenever a conductor is carrying electrical energy current through all three passive elements, current through the all three passive elements R, L, C will always flow from positive terminal to negative terminal. This is thumb rule. Okay, in general, if you take any element, the current carrying through that particular element is from positive to negative direction. Okay, so here the current is flowing from positive to negative, here also current flowing from positive to negative terminal, here also current flowing from positive to negative terminal. In general, if you consider any element, always the current chooses positive terminal to negative terminal. The current flow passing from positive to negative terminal, that you have to remember, right? That is in general. Okay. In the next condition, historical approach. Okay, so we have two theories. One is network theory, and another one is field theory. Right now we are dealing with this network theory subject, and this subject, okay, this network theory is applicable up to 1 megahertz frequency, okay. That means 0 to 1 megahertz frequency we need to go for network theory. Okay, so above 1 megahertz frequency we need to go for field theory approach. Okay, field theory approach. That means for higher frequencies greater than 1 megahertz means we can consider these frequencies are higher frequencies, right? So for greater than 1 megahertz we should consider as higher frequencies. Up to 1 megahertz, okay, that means less than 1 megahertz, so we can treat as lower frequencies. Okay, that means network theory is valid for only lower frequencies. So if you want to analyze higher frequency circuits, okay, so that means what, under 1 megahertz frequency, whichever the circuit we are design, whichever the circuit we can able to design, those all are lower frequency circuits, right? So if we are designing one RLC circuit, this is a resistor and this is capacitor and this is inductor, and here I am applying plus or minus 5 volts battery. This is R and this is C. This is one series circuit, series RLC circuit, right? So the series RLC circuit is called as lower frequency circuit. Okay, lower frequency circuit. Why? Because so lower frequency circuit. Okay. Why? Because this can be operated under 1 megahertz only. Okay, this entire circuit can be operated under 1 megahertz only. Above 1 megahertz, this circuit is not valid. Okay, that's why we can call it as lower frequency circuit, and we can analyze the individual branch voltages and currents with the help of network theory only. Okay, so if you get any circuit above 1 megahertz, that comes under field theory. So we need to evaluate the parameters with the help of field theory only. Okay, we need to evaluate parameters with the help of field theory. Okay, so here we have one more point. This field theory can be applicable 0 to high frequencies. Okay, so that means what, in this network theory place also we can use field theory to evaluate this circuit, right? But we cannot get accurate values with this field theory. Okay, so this field theory can be applicable from 0 frequency onwards. Okay, but so from 0 to 1 megahertz we are preferring network theory to get the accurate results. Okay, even field theory also, field theory యూస్ చేసి కూడా మనం క్యాలిక్యులేట్ చేయొచ్చు, బట్ we can't get the accurate values. Okay, that's why we are focusing network theory to evaluate 0 to 1 megahertz frequency. Okay, And in this low frequency, so here we have certain differences. So for example, if I am taking low frequency circuits, this is low frequency circuit, low frequency circuits, and high frequency circuits. Okay, so generally, so here we have certain conditions. For example, if you are taking electron, right? So this electron is in static mode. Electron is in static mode. Static mode is nothing but rest mode. Okay, so that means there is no movement at all, right? Rest mode. Okay, so whenever electron is in static mode, which produces electric field in its surrounding. Okay, in its surrounding in unidirectional manner. That means equal manner. Okay, for example, in this position we have electron up to certain distance which produces electric field. That means when electron in static mode which produces only electric field, right? Only electric field. Okay, for example, this electron moving with certain velocity, electron moving with velocity. Okay, so in that case it produces electromagnetic field. Okay, electromagnetic field. So in the first case, electron is in rest mode. In that case, which produces only electric field. And the second case, electron moving with certain velocity. In that case, electron, that means when electron moving with certain velocity, which produces electromagnetic field. Okay. In third case, electron moving with certain acceleration. Acceleration. In this situation, which produces electromagnetic radiation. Electromagnetic radiation. Okay, that means what? Acceleration means what? So velocity per meter, sorry, velocity per second, right? Every second velocity changes. Okay, here velocity, sorry, meter per second. Every second the traveling distance changes, but here every second traveling velocity changes. Okay, that is the difference. Okay, so when electron is in rest mode, electric field produces. When electron moving with certain velocity, which produces electromagnetic field. When an electron moving with certain acceleration, then it produces electromagnetic radiation. So these are the difference between electric field, electromagnetic field, and electromagnetic radiation. Okay, just you remember these 3 points, right? So now, for example, if I am taking one simple resistive circuit, so here we have two resistors R1, R2, and here I am connecting plus or minus 5 volts battery, right? So here always the current flows from positive to negative terminal. If you this is 5 volt source, right? Source, otherwise battery. So whenever you consider source, always electron coming out from positive terminal. Okay, whenever you consider source, always current coming out from positive terminal. So this is your positive side, this is your negative side. So current coming out from this positive symbol, right? So that this is your current, right? So whenever current carrying through this particular wire, copper wire, so whatever the circuit here we are using, whatever the material we are using in this circuit, that is copper wire. So the current carrying through this copper wire, so it produces, that means the current carrying means what? This is electron direction, right? So this is plus and this is minus. Electron moving from positive, sorry, negative to positive. So what about the current direction? Always from opposite to this electron direction. Okay, electric field direction and force direction both are in opposite. In the same way, electron direction and current direction both are in opposite. Okay, the starting class only I told you, electric field and force both are in opposite direction, and electron direction and current direction both are in opposite, right? So for example, here current direction is in this way, that means electron direction is opposite to that of this current direction, right? So whenever electron moving with certain velocity, there should be electromagnetic field, right? Electron is in rest mode, we can expect electric field. Electron moving with certain velocity means what? Electromagnetic field we can expect, right? So here electron moving in this particular direction. So obviously we can get electromagnetic field surrounding this particular copper wire, right? So entire this copper wire, electron is moving, right? So while traveling this electron, there should be electromagnetic field which is surrounded by this particular copper wire. That means outside the copper wire we can expect electromagnetic field. Okay, that means here we have two things. Here we can observe two things. One is, while traveling this current through this particular element, here we can expect certain voltage drop V1, here we can expect certain voltage drop V2, right? While traveling this current through these elements, we can expect voltage drop V1, voltage drop V2. Okay, so here we have I value, here we have R value, and here we have V value. That means I, V, comma R values. This is one case. Okay, and in the next case, in throughout this wire, so we can expect electromagnetic field because of electron movement, because of electron velocity, right? So that is another way. That is electric field comma magnetic field H. So these two fields are experienced by this particular copper wire. That means electric field and this magnetic field always in perpendicular direction. That means so this is your electric field, right? This is your electric field. For this electric field we can expect perpendicular. That means angle between this electric field and magnetic field is 90 degrees, so that we can expect magnetic field curve like this. Okay, okay. So this is magnetic field and this one is electric field. Okay, like this we can get the electromagnetic field curve throughout this wire. Okay, that means physical parameters, the current, voltage, resistor is one side, and this electric field and magnetic field is another side. But this entire low frequency circuit, we can ignore this electric field, magnetic field. Only we can focus these physical parameters I comma V comma R. When you are solving this entire network, we are focusing these parameters only. We can completely ignore this electric and magnetic field. Why? Because of this electromagnetic field, these parameters will not affect. Okay, because of this electromagnetic field, okay, electromagnetic field strength, so these parameters will not affect. So that's why we are ignoring these fields, okay, which are produced in this particular circuit. Okay, అంటే ఏంటంటే ఇక లో ఫ్రీక్వెన్సీ సర్క్యూట్స్లో ఏదైతే ఫీల్డ్స్ జనరేట్ అవుతున్నాయో ఆ ఫీల్డ్స్ వల్ల ఫిజికల్ పారామీటర్స్ ఐ కానీ వోల్టేజ్ కానీ ఆర్ కానీ అఫెక్ట్ అవ్వట్లేదు. సో అలా అఫెక్ట్ అవ్వనప్పుడు ఫీల్డ్స్ని కన్సిడర్ చేయాల్సిన అవసరం లేదు లో ఫ్రీక్వెన్సీ సర్క్యూట్ అనాలిసిస్లో. ఓకే, లో ఫ్రీక్వెన్సీ సర్క్యూట్ అనాలిసిస్లో ఏం చేస్తున్నాం మనం? ఓన్లీ ఐ కామా వి కామా ఆర్ వీటి మాత్రమే కన్సిడర్ చేస్తున్నాం. ఈ కామా హెచ్ని ఇగ్నోర్ చేస్తున్నాం, ఎందుకంటే వీటి ఎఫెక్ట్ ఈ సర్క్యూట్ పైన నెగ్లెక్టెడ్. సో దట్స్ వై మనం వీటిని ఇగ్నోర్ చేసేస్తున్నాం. అంటే లో ఫ్రీక్వెన్సీలో మనం ఏంటి, ఓన్లీ వన్ వే ఆఫ్ అనాలిసిస్ మాత్రమే కన్సిడర్ చేస్తున్నాం. అది ఐవిఆర్, ఓమ్స్ లాని బేస్ చేసుకొని, కేసీఎల్ కేవీఎల్ లాస్ని బేస్ చేసుకొని మాత్రమే మనం సర్క్యూట్ని ఎవాల్యుయేట్ చేస్తున్నాం. ఇక్కడ ఫీల్డ్స్ని కన్సిడర్ చేయట్లేదు. బట్ హయ్యర్ ఫ్రీక్వెన్సీలో కంప్లీట్లీ ఆపోజిట్. దిస్ ఐ కామా వి కామా ఆర్ని కంప్లీట్గా ఇగ్నోర్ చేసేస్తాం. ఓకే, we can ignore these physical parameters and we can focus only on electric field, magnetic field and electromagnetic field. ఈ త్రీ థింగ్స్ పైన మనం ఫోకస్ చేస్తాం. ఓకే, అంటే బై using this electric field, magnetic field, electromagnetic field, we can evaluate the high frequency circuit. In this high frequency circuit analysis, we simply ignore these physical parameters I, V, R. Okay, so that is the difference. Okay, so this is about low frequency and high frequency circuits. And and here one thing is what, so this field theory can be applicable for all the frequencies, right? From 0 to higher frequencies, for all the frequencies field theory approach is applicable. But in order to evaluate the low frequency circuits, network theory is accurate one while comparing to field theory approach. Why? Because the field theory should in field theory, so we need to consider electric field as well as magnetic field also. Okay, that's why we are preferring only network theory to evaluate the low frequency circuits. Okay, and this is difference between low frequency and high frequency circuit. And in the next slide, I will take two conditions. Okay, scenario 1, otherwise case 1. So here, and the second one is case 2. And one more thing, in this low frequency circuit, so what are the elements we are using in this low frequency circuit? We can treat as those are lumped elements. Okay, we can call it as lumped elements. While coming to this high frequency circuits, whatever the elements we are using in this high frequency circuits, which are called distributed elements. Okay, distributed elements. Okay, lumped elements and distributed elements. Here majorly we can focus on RLCs, right? R comma L comma C. Okay, in this distributed lines we are using conductors. Okay, okay. So now in this distributed elements we should be considered as waveguides, microstrip lines. Okay, like that we have various devices to form the high frequency circuits, right? And next coming to case 1. Okay, 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 right. So in the presence of active sources, in the presence of active sources, and the case 2, in the absence of active sources. Okay, so here in the presence of active sources means for example, if I am taking RLC circuit here, so this is our source, right? This is our source and this is our network. Okay, here we have one resistor R1, R2 and LC. Okay, this is our source. So presence of active source is nothing but this source is active source here. So which is nothing but active source, and this is applicable to this entire network, right? This is applicable to this entire network. That means this network in the presence of this active source, this network in the presence of this particular active source. In this situation, so current direction always from positive to negative terminal for all the elements. Here we have two resistors, one capacitor, one inductor. In the presence of active sources, the current direction always from positive to negative terminal. Okay, in the presence of active sources, the current direction, okay, the current direction for resistor, okay, positive terminal to negative terminal, for inductor positive terminal to negative terminal. Okay, and for capacitor also the current direction is from positive terminal to negative terminal. This is applicable only when presence of active sources. Okay, so what about in the absence of active sources? So now same circuit if you consider here, So here I am taking plus minus, this is active source, okay, and here I am connecting one switch, okay, and this is your resistor, and this is your resistor, and this one is inductor and capacitor, right? So and this is R1, R2, L and C, okay. So here at t is equal to 0 and switch is open, otherwise I will take in this direction, okay. I will consider in this direction. That means at t is equal to 0, switch is open, okay. So now what happened? Before t equals 0, the switch is closed, the circuit will act as that means the presence of active sources, like, right? So when t equals 0, switch is open. Now the circuit is the final circuit is like this, right? The active source is disconnected from this entire circuit, okay. This active source disconnected from this entire circuit. So now we can expect the final circuit like this, okay. This is our final circuit. So in this circuit we don't have any active source, right? In this circuit we don't have any active source. That means what? This circuit act as absence of active source, okay. So for example, if I am taking, this is minus infinite, plus infinite, and this is t, okay, and t equals to 0, and this is minus t, and this is plus t. So minus t is nothing but 0 minus second, plus t is nothing but what? 0 plus second, okay, within 0 time. That means 0 minus 0, 0 plus. In this time, switching action can be performed, right? So minus infinite to up to t, switch is closed, right? At t is equal to 0, switch is opened, okay. Up to minus infinite to t is equal to 0, switch is closed, right? So when t equals to 0, switch is opened. When t after t equals 0 and t greater than or equals to 0, from this t greater than or equal to 0 condition, the circuit will act as absence of active sources. That means that is source free circuit, okay. After t greater than or equal to 0, the circuit called as source free circuit, okay, source free circuit. So here you can observe minus infinite to t equals to 0, minus infinite to t is equal to 0, the circuit act as with source circuit. That means in that particular circuit active source is present, right? Whenever active source is present, these L and C, okay, capacitor and inductor, these two elements act as memory elements, otherwise storage elements. Memory elements are storage elements, memory elements, otherwise storage elements, okay. That means what? So these two elements, that means capacitor and inductor, which are called as energy storage elements. So that means which stores the amount of energy, okay. L and C are called energy storage elements, energy storage elements, okay. That means which stores the amount of energy from the active source, okay, from the active source, but resistor always dissipated amount of energy, okay, always dissipated energy, which do not store the energy, any amount of energy, okay. Always resistor dissipates the energy, but L and C elements are always stores the energy. Certain amount of leakage energy also there through this L and C elements also. L and C always stores the energy, but these L and C also having certain amount of resistance. For example, if you take coil, so this is your inductor. So this inductor manufacturing with the help of certain material, okay, that coil made up of certain material, okay, that material having certain amount of resistance, right? This material having certain amount of resistance. Due to this resistance means what? Which dissipates energy. Always this resistance dissipate the energy. దీనికి ఈక్వలెంట్ సర్క్యూట్ ఎలా తీసేసుకోవచ్చు మనం? దిస్ ఈజ్ ఇండక్టర్, ఓకే, అండ్ దిస్ వన్ ఈజ్ రెసిస్టర్. సో ఈ మెటీరియల్కి ఏదైతే రెసిస్టెన్స్ ఉంటుందో దాన్ని ఇక్కడ స్పెసిఫిక్గా మెన్షన్ చేశాను, ఓకే. ఇది ఇది ఈక్వలెంట్ సర్క్యూట్, ఓకే, ఫర్ దిస్ ఇండక్టర్. ఐడియల్ కేసులో ఏంటి అంటే రెసిస్టెన్స్ని మనం జీరోగా తీసేసుకుంటున్నాం, అప్పుడు ఎలాంటి రెసిస్టెన్స్ ఉండదు అని, ఓకే, అది ఐడియల్ కేస్. బట్ ప్రాక్టికల్గా రెసిస్టెన్స్ లేకుండా మనం కాయిల్ని ఫామ్ చేయడం అనేది ఇంపాసిబుల్, ఓకే. డెఫినెట్గా ఏదో ఒక మెటీరియల్ యూజ్ చేస్తాం, ఆ మెటీరియల్ రెసిస్టెన్స్ అయినా మనకు అక్కడ ప్రొడ్యూస్ అవుతుంది, ఓకే. ఇన్ ప్రాక్టికల్ కేసులో మనం ఇండక్టర్ ప్లస్ రెసిస్టర్గా తీసుకోవాల్సి వస్తుంది. ఈ రెసిస్టెన్స్ ఏంటంటే ఈ మెటీరియల్ ఏదైతే యూజ్ చేస్తామో ఆ మెటీరియల్ రెసిస్టెన్స్ ఇక్కడ కన్సిడర్ చేసుకుంటున్నాం, ఓకే. రెసిస్టెన్స్ ఉంది అని అంటే డెఫినెట్గా సర్టెన్ డిసిపేషన్ అనేది ఉంటుంది. ఇండక్టర్ స్టోర్ చేసుకుంటుంది, ఓకే, ద స్టోరేజ్ ఈజ్ డిఫరెంట్, ఓకే. బట్ దీనికి ఉన్న మెటీరియల్ రెసిస్టెంట్ వల్ల హీట్ ఫామ్లో సర్టెన్ అమౌంట్ వచ్చేసి డిసిపేట్ అవుతూ ఉంటుంది. అంటే సర్టెన్ లీకేజ్ కూడా మనకి ఎక్స్పెక్ట్ చేయొచ్చు త్రూ ఎల్ అండ్ సి ద్వారా, ఓకే. దట్ ఈస్ మినిమం లీకేజ్, ఓకే. స్టోరేజ్తో పాటు మనకి ఇక్కడ లీకేజ్ కూడా ఉంటుంది. సో ఆ లీకేజ్ వచ్చేసి ఇగ్నోర్ చేయొచ్చు మనం, ఓకే. సో మీకు ఎల్ అండ్ సి ఎలిమెంట్స్ అనగానే మీకు గుర్తు రావాల్సిన థింగ్స్ ఏంటంటే దీస్ ఆర్ ఎనర్జీ స్టోరేజ్ ఎలిమెంట్స్, ఓకే. రెసిస్టెన్స్ మీన్స్ విచ్ ఆల్వేస్ డిసిపేట్స్ ద ఎనర్జీ, ఓకే. సో ఇన్ దిస్ కేస్ మనకి ఇక్కడ కండిషన్ ఏం మెన్షన్ చేశాను నేను ఇక్కడ, -∞ టు t0 టైం వరకు స్విచ్ అనేది క్లోజ్ చేసి ఉంటుంది. అంటే ఆ పర్టికులర్ డ్యూరేషన్లో ఈ R1 కానీ R2 కానీ L కానీ C కానీ ఇవన్నీ ఎంటైర్ నెట్వర్క్ ఈ సోర్స్కి కనెక్ట్ అయి ఉంది, రైట్. ఎప్పుడు -∞ టు t0 వరకు, రైట్. ఈ పర్టికులర్ డ్యూరేషన్లో స్విచ్ క్లోజ్. సో ఈ యాక్టివ్ సోర్స్ వచ్చేసి ఈ పర్టికులర్ నెట్వర్క్కి కనెక్ట్ అయి ఉంది. ఇప్పుడు ఈ యాక్టివ్ సోర్స్ ఏదైతే ఎనర్జీ ప్రొడ్యూస్ చేస్తుందో ఆ ఎనర్జీ కంప్లీట్ అమౌంట్ ఆఫ్ ఎనర్జీని ఎల్ అండ్ సి ఎలిమెంట్స్ వచ్చేసి కంప్లీట్గా స్టోర్ చేసేసుకుంటాయి, ఓకే. సో వెన్ ఎవర్ దిస్ యాక్టివ్ సోర్స్ కనెక్టెడ్ టు దిస్ పర్టికులర్ నెట్వర్క్, in that particular duration this L and C element stores the energy from this active source, but this R1 and R2 resistors are always dissipates the energy. This R1 and R2 resistor dissipates the amount of energy from -∞ to t, from -∞ to t is equal to 0. అంటే ఇది కనెక్ట్ ఈ పర్టికులర్ టైం పీరియడ్లో ఈ టూ రెసిస్టర్స్ వచ్చేసి ఎనర్జీని డిసిపేట్ చేస్తాయి, ఓకే. బట్ ఎల్ అండ్ సి ఎలిమెంట్స్ వచ్చేసి కంప్లీట్గా అమౌంట్ ఆఫ్ ఎనర్జీని స్టోర్ చేసేసుకుంటాయి, రైట్. ఇప్పుడు t0 దగ్గర స్విచ్ వచ్చేసేసి నేను రిమూవ్ చేశాను. అంటే బిఫోర్ స్విచ్చింగ్ యాక్షన్ కరెంట్ అనేది ఇందులో క్యారీ అవుతూ ఉంటుంది, రైట్. కరెంట్ త్రూ దిస్ R1 రెసిస్టర్, కరెంట్ త్రూ R2 రెసిస్టర్, కరెంట్ త్రూ L అండ్ కరెంట్ త్రూ C. దట్ మీన్స్ ఎలక్ట్రికల్ ఎనర్జీ కరెంట్ త్రూ ఆల్ దీస్ ఎలిమెంట్స్ ఫ్రమ్ పాజిటివ్ టర్మినల్ టు negative terminal, from positive terminal to negative terminal, okay. If you take this resistor, current flowing from positive terminal to negative terminal, and here also current flowing from positive to negative terminal, here also current flowing from positive negative terminal. So our first case is what? In the presence of active sources, the current direction always from positive terminal to negative terminal for resistor, for inductor, for capacitor also, right. So here also -∞ to t is equal 0 switch is closed. That means this is the first condition, right. In the presence of active source, in that case for all the elements current is flowing from positive to negative terminal. So while carrying electrical energy, R1 R2 dissipates the energy, L and C elements are stores the energy. So this thing happen when -∞ to t equals to 0. Now at t is equal 0 switch is open. Now circuit becomes source free circuit. That means this will comes under absence of active source condition. Here we don't have any active source. In that situation this R1 R2 will not have any amount of energy, okay. Why? Because ఈ పర్టికులర్ డ్యూరేషన్లో కంప్లీట్ అమౌంట్ ఆఫ్ ఎనర్జీని డిసిపేట్ చేశాయి, బట్ ది ఎల్ అండ్ సి వచ్చేసి అమౌంట్ ఆఫ్ ఎనర్జీని స్టోర్ చేసుకున్నాయి ఈ పర్టికులర్